Hey guys. So today we're gonna start talking about the quadratic formula. We're gonna use today's class and next class to discuss it. Today we're just gonna figure out what kind of answers we should get from the quadratic formula, and next class we'll actually find those answers. And then the last class we will hopefully look at applying some of the quadratic functions. So we're gonna connect this to what we did last class and see if we can take it a bit further. One thing that I hope you start to realize about the quadratic formula is that it's really kind of your best friend, because if you have trouble with factoring, if you're not super solid with factoring, which I hope by now you are, but if you're still not, the quadratic formula is something that we know always works, whereas factoring, sometimes we try some ways. There's so many different ways we can factor, and sometimes there really isn't any kind of factoring that actually works to get you the answers, because the answers are obscure irrational numbers. But the quadratic formula always works no matter what kind of answers we should expect to get. So in that respect, it's pretty helpful. And there is a really, I won't say annoying, but catchy, we'll use the word catchy, quadratic formula song if you're a little musical, and you might like it, and it'll be stuck in your head for days and days and days. It's to the tune of Pop Goes the Weasel. So I'll post that for you too, so you can watch that. Don't worry, I'm not singing, someone else's. Anyway, let's dive in. So quadratic formula is this right here, and it's to solve for x. And remember, you should have two x values when you're solving a quadratic, because it begins with x squared. They might be the same number. They might be giving us an error when we try and find the answer, but there's always two of them, okay? So quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So that's the whole thing. And this quadratic formula, we're really going to use the full thing next class. For today, we're just going to focus on what we call the discriminant, which is just that piece under the square root, okay? So the discriminant helps us discriminate against, or I shouldn't say discriminate against. We're not discriminating against anything, even if it's math. Discriminate between the types of answers you should get, okay? And the A, B's, and C's in that discriminant come from the standard form of a quadratic function, ax squared plus bx plus c. So our job is going to be to identify those values a, b, and c, and then substitute them into the quadratic formula just in the discriminant part, and then use a few rules to see what kind of answers we should get, okay? But before we jump into that, let's connect this to what we did last class, okay? So this statement here says there are three possible outcomes when you take the square root of a real number n. In last class, we worked on solving with the square root method. So the first says that when n is greater than 0, which all that means is when n is positive, you should get two real values, one positive and one negative. So when we had a problem that looked like n squared is equal to positive 16, when this value is positive, we can go ahead and take the square root. Well, we know the square root of 16 is 4, and remember, we always get a positive and a negative answer. So plus or minus 4, one positive, one negative. That gives me two real answers, and that correlates to a graph, right? When I have two real solutions for a parabola on a graph, that means it's crossing the x-axis in two places. Those are the zeros of the function. So when n is positive, greater than 0, or positive, we can say, our graph is going to look something like that, where it crosses the x-axis in two particular places, okay? We also could have a problem where the n was equal to 0. So if I have n squared equals 0, if I go and take the square root of that, well, think about that. Do you get positive and negative 0? Hopefully you're saying no. there's only one 0, right? So our answer is just n equals 0, and that's why when it's equal to 0, we only get one real value, okay? So if n is equal to 0, then we get one real solution. And what that means is that our graph is going to touch the x-axis. It's just going to like kiss it and turn back around, or it could be facing upside down also. And that it's only hitting on one value. So we call it sometimes a double root. If you had a factor of something like this, it would be a perfect square trinomial where both factors are the same. But it just means we get two answers. They happen to be the same thing, okay? And we also looked last time at situations where we had a negative value. So if we got to n squared equals negative 16, and then we try to take the square root, well, when we put that in our calculator, we got something that just said error, right? If you watched the extension video, you saw that can actually translate into an imaginary answer. Well, the square root of 16 is 4. The negative, we get an I from that. It's imaginary. And we also have plus or minus. But for our purposes, here, if it's less than 0, we have no real answers, no real values. Okay? What does that look like on a graph? That means my graph is not touching the x-axis at all. It's either hovering below or above. And so that happens when that value is negative. Okay? Same thing is going to happen with our discriminant. A discriminant is just something we can use when we can't use the square root method, when we can't just go and take the square root. But it's still underneath a square root symbol, right? So similar rules are applying. If it's a positive number, I can take the square root of that and get two real answers. If it's 0, then I can take the square root, but I only get 0 as an answer. And if it's negative, then I can't take the square root of it, okay? So we're going to do the discriminant here, b squared minus 4ac, but the same rules apply, okay? So if b squared minus 4ac is positive, then we're going to get two real solutions. Excuse me. If b squared minus 4ac is equal to 0, then I'm going to get one real solution. And if b squared minus 4ac is negative or is less than 0, we're going to get no real solutions. So you have this little chart up here to help you. So let's see if we can calculate a few of these, and then our job is going to be able to come back to the chart and say, what type of answers am I actually getting here? Okay, so on to the first example. We have 5x squared plus x minus 2 is equal to 0. First step when you do these problems is get your equation equal to 0. All right. Second step is to identify a, b, and c. And remember, that's coming from a, x squared, plus bx plus c. Standard form of a quadratic. Well, if I want to find a has to be the number in front of x squared. So in our case here, a is going to be 5. B is going to be the number in front of the singular x. If we don't see anything there, we assume it to be a 1, right? And you always take the sign that's in front of it. So I mean, we should have drawn that a little better. So b is equal to positive 1. And then c is the constant value. And again, take the sign that's in front. So c is equal to negative 2. All right. So now we're going to fill in our discriminant. We're going to simplify this. And in order to do that, I need to substitute in the numbers that I have for a, b, and c. So first thing is b squared, and we said b is 1. So I'm going to replace b with 1. Then we have the minus 4 is always there. Then we have times a, and a we said is 5. And then times c, and c we said is negative 2. And then we're going to simplify using PEMDAS, right? So b squared, we're doing the exponent first. There's nothing to do inside of parentheses, so I don't have to worry about that. So in my exponent, 1 squared is going to be 1. Remember, anything that comes out of what's being squared is always positive. And then I'm going to do my multiplication, that's all this is here, from left to right, okay? So negative 4 times 5 is negative 20. And then I do negative 20 times negative 2 is positive 40. And 1 plus 40 is 41. So now our objective is to look at this number. This is your discriminant, okay? We want to decide, is this number positive, negative, or 0? Well, 41 is positive. So if I'm answering the question, how many real solutions do I have to this problem? If we get a positive answer, that tells me I have 2 real solutions, okay? When that value is positive, 2 real solutions. So it would be crossing the graph in 2 places. All right, and that's all there is to it. So we're going to set the equation equal to 0. We're going to identify a, b, and c, and then we're going to substitute values into b squared minus 4ac. Okay, and then after that, it's just about determining what your answer tells you. Let's try another example. So negative 2x squared minus 8x minus 14 equals negative 6. First thing is to get it equal to 0, so I need to bring the 6 to the other side by adding it. And I want to match it up with its like term, so it's similar to 14, so I'm going to add it there. So that gives me negative 2x squared minus 8x minus 8 equals 0. So now I need to identify a, b, and c. Well, remember we're pulling from ax squared plus bx plus c. So I think a is going to be negative 2. B is going to be negative 8. And C is going to be negative 8 also. So now if I'm filling in b squared minus 4ac, I'm going to have b squared, which is negative 8 squared, minus 4 times a, and a is negative 2, times c, and c is negative 8. Now follow our PEMDAS. Negative 8 squared is positive 64. If you're putting that into your calculator, don't forget to use parentheses around the negative 8. Otherwise, it's going to give you negative 64, and then you'll get the wrong answer. And then we're going to do our multiplication left to right. Well, negative 4 times negative 2, that is positive 8 times negative 8. So I have 64, and then 8 times negative 8 is negative 64. Well, 64 minus 64 is 0. So when I get a discriminant that's equal to 0, that tells me I have 1 real solution. So my graph is going to cross, or it's just going to hit the x-axis in one place, okay? So 1 real solution here. And again, that's because the square root of 0, you're only getting 1 answer out of that. So we can't get more than 1 possible 0 or 1 possible solution. All right, let's try one more example here together. So again, get the equation equal to 0. I'm going to do that by adding 10, matching it with its like term. So 9n squared minus 3n plus 2 is equal to 0. Now, I want to identify A, B, and C. And I'm sort of just showing you different ways to do it as I go. But A is the number in front of x squared, so A is 9. B is in front of x, so B is -3. And C is the constant, so C is 2. Now we fill in our discriminant. B squared would be -3 squared minus 4 times A is 9 and C is 2. Some of you have calculators where you could enter this entire line and your calculator will give you out an answer. Others of you might have to do it more step by step. So play around with your calculator and get comfortable with which version you have. Or you can use your good old noggin. So start with PEMDAS. We're squaring exponents. We're doing exponents first. -3 squared is 9. -4 times 9 is -36 times 2. -36 times 2 is -72. 9 minus 72 is -61, right? So here, oh sorry, no, I messed it up, 63. Maybe we should use a calculator. So the negative answer for my discriminant tells me, right, we can't really take the square root of a negative answer, so I get no real solutions or no real roots. Excuse me. I was trying to hold that cough in for a while. I've been talking all day. So anytime you get a negative answer for your discriminant, you have no real solutions. So your graph is not crossing the x-axis at all. It's floating above or below. So just like usual, go ahead and try your practice questions. You only have to do the circled problems on that paper. Well, I guess you don't technically have to do any of them, but if you do those, submit your work to that assignment for 1 point, and then try the quiz where you have 3 chances, okay?